Yeah, greetings, my beloved audience. Happy New Year to each and everyone. Today we are going to be looking at mathematics, and our topic is vectors. We have heard about vectors also in physics. A vector quantity has both magnitude and direction. Yes. So now then, a vector quantity is being represented using an arrow, and that arrow, yes, that arrow, the sharp point is the head. Then the other point will be the tail. So if you have something like this is the head of that vector, and this will be the what? The tail of the vector. Then we have what we call algebra of vectors. Algebra has to do with something like addition, subtraction, multiplication, division. So let's look at algebra of vectors. Algebra of vectors. So here we'll be looking at yes, addition and subtraction of vectors. Addition and subtraction of vectors. Now, if you have something like this, maybe if maybe a vector A is equals to, let's say, 5i plus 3j. You have another vector B is equals to 6i plus, let's say, maybe 9j. And you are being asked to maybe find I vector A plus vector B. Then the next question, maybe you are being asked to look for vector A minus vector B. It will be very simple. For you to add or subtract vectors, just you take their corresponding components together. So for example, this one now, solution. So vector A plus vector B simply means I should add corresponding components. 5i plus 6i will give me 11i. Then 3j plus 9j is going to give me 12j. That is the answer to that question based on addition. Then for the subtraction, vector A minus vector B will be 6i minus 5i minus 6i will be minus I. Then 3i or 3j minus 9j will be minus 6j. That becomes the answer to that question. So that's what the addition and subtraction of vector all about. So for you to add or subtract vectors, you take the corresponding components, you bring them together. This is for a two-dimensional vector. They will have three-dimensional vector. Let's say one. So let's look, if we have something like this. If P is equals to 7i plus 13j minus 4k, and the vector Q, yes, is equals to maybe 4i plus 6j plus 9k. Then we are being asked to find the vector P plus vector Q. I vector P minus vector Q, something like this. So this is a three-dimensional vector. Solution. So I think the first question is vector P plus vector Q. So vector P plus vector Q. This will be 7i plus 4i will be 11i. 13j plus 6j is going to give us 19j. Then minus 4k, minus 4k plus 9k is same as 9k minus 4k, which will be what? 5k. And that is the answer to that first question. Then the second one, vector P minus vector Q, means you subtract corresponding components. 7i minus 4i is going to give us 3i. Then 6j minus, no, 13j minus 6j will give us 7j. Then minus 4k minus 9k will be minus 13k. That's the answer to this one. So that's what the addition and subtraction of vectors are all about. So I think we are through with the addition and subtraction. So the next thing we are going to look at now is what we call the modulus of a vector. Yeah, and the modulus of a vector simply means the length of the vector, which somehow we can apply Pythagoras theorem, especially when it's two-dimensional. So we have modulus of a vector. Now, for us to look for the modulus of a vector, let's assume that a vector is being given like this. Let us say A is a vector. If A is a vector, then its modulus will be denoted as it. So that modulus, that absolute means we are looking for the length. So if I have something like this, if a vector is given as A equals to xi plus yj, then the modulus of this vector, yes, will be given as square root of x squared plus y squared. That will be the modulus of the vector. We can take an example, e.g., if the vector A maybe is equals to 6i plus 8j. If A is this, then you are being asked to find this. How do we just give you in the exam? They say find this. And that thing simply means find the what? The modulus of the vector. So solution. The modulus of this vector will just be simply equals to square root of, you take the coefficients of the I and j component, that's 6 squared plus 8 squared. Then this will give us 6 squared means 6 times 6, which is 36. 8 squared means 8 times 8, which is 64. This will give us 36 plus 64 will be 100. And the square root of 100 is going to be 10. So that which means the modulus of that vector, the modulus of the vector is 10. And you can represent it in a diagram. This is the I component. The I is like the horizontal. J is the vertical or the ordinate. So here is 6. So we'll have 6 here. Then here is maybe 8. So you see that if you extrapolate it, they'll meet somewhere here. And that point there is 6,8. Then we're now looking for the line from the origin, this point. That is where we'll have the modulus of that vector. And here is 90 degrees. So can I apply Pythagoras theorem? And Pythagoras theorem says that for a right angle triangle, the square of the hypotenuse side is equal to the sum of the squares of the other two sides. So from here, absolute of A square will be equals to the length from here to here, which is 6 square plus, from distance from here to here is the same as from here to here is 8, and here is 6. So this is 8 square. And 6 square is 36. 8 square is 64. And 36 plus 64 will give us 100. So this is absolute of A square. So here the absolute of A will be equals to square root of 100. And the square root of 100 is going to be 10. So that's what the modulus is all about. Then also, this is for 2 dimension. They can still give us also for 3 dimension. Like we have something like, maybe let me give you 2 or 3 seconds to go through this one. Okay, so then let me give an example. This is example in 2 dimension. This is a 2-dimensional vector. Then we'll have what we call 3-dimensional vector. That will be I, the unit vectors will be I, J, and K. So we have something like this, maybe e.g. if maybe P, the vector P is equals to maybe 3i plus 5j minus 7k, then you are being asked to find, this thing simply means find the modulus of this vector. So for us to get the modulus of this vector, this will now be solution. The modulus of the vector will simply be equals to square root of, you take the coefficients of I, J, and K, they will square them. So this will be 3 square. Here will be 5 square. Here, if you say 7 square, it is wrong because the coefficient of K is minus 7. So it is minus 7 all square. So this is bracket negative 7 all square. So this is going to give us square root of 3 square means 3 times 3, which is 9. 5 square means 5 times 5, which is 25. Negative 7 square means negative 7 times negative 7, which is 49. So this is going to give us, this plus this is going to give us 34 plus 49. 4 plus 9 is 13. You carry 1, add here 4. 4 plus 4 is 8. So this will be 83. Yeah, and that will be the modulus of that vector, because square root of 83 cannot be simplified further. We will not like to go with decimal. So this is the modulus of that 3 by 3 vector. So we are through with modulus of the vector. Yeah, yes, we are through the modulus of the vector. So now let us now look at what we call unit vector. That word unit means one. Unit vector. Yes, and a unit vector is a vector whose modulus will be equals to 1. So let's watch. So if a vector is denoted, if a vector is denoted as A, comma, then its unit vector is given by, the unit vector will be given by U cap. This U cap means a unit vector. That is, the unit vector U cap simply means the vector that was given all over the modulus of that vector. So this is what it is. So this is the formula. Yes, for unit vector. For you to get the unit vector, you take the vector divided by its modulus. Let me give an example. E.g., the first example, if maybe the vector A is given as 3i plus 4j, comma, find U cap, or just maybe find the what? Unit vector. Find the unit vector in the direction. Find the unit vector in the direction of A. Yeah, so if A equals to 3i plus 4j, find the unit vector in the direction of A. So solution. I'll first get the modulus of this vector. Yes, the modulus of this vector simply means square root of 3 square plus 4 square. And 3 square is 3 times 3. 4 square is 4 times 4, which is 16. And 9 plus 16 will be 25. And square root of 25 is going to be 5. So this is it. So then I want to get the unit vector. The unit vector is given as U cap, which is given as the vector A all over its modulus. So which means the vector A is what? 3i plus 4j all over the modulus of A. Modulus of A is 5. And in mathematics, if somebody gives you something like A plus B over C, simply means A over C plus B over C. That's a distributive property. Because even in primary school, we're being told that when the denominators are the same, take one of the denominator, add the numerator. So it's the same thing. So if somebody gives you something like maybe 8 plus 4 divided by 2, this is the same as 8 plus 4 is 12. 12 divided by 2 will be 6. You can still write it as what? 8 over 2 plus what? 4 over 2. 8 divided by 2 is 4. 4 divided by 2 is 2. It will still give you 6, which is the same as this 6. They are still the same thing. So here, this can be written as 3 over 5i plus 4 over 5j. So this is the unit vector U cap. What shows that this is the unit vector? If you take the modulus of this vector, it is equals to 1. Because a unit vector is a vector whose length is equals to 1. Let's find out. So let's prove. So I want to get the modulus of that vector. The modulus of U cap. This will be equals to square root of 3 over 5 all square plus 4/5 all square. So actually, that will give me 3 square is 9, 5 square is 25, 4 square is 16, 5 square is 25. So I'll add that. That will give me square root of 9 plus 16 will be 25/25. And 25 divided by 25 is 1, and square root of 1 is equals to 1. So that's actually what we mean by a unit vector. So a unit vector actually is a vector whose modulus or whose length is equals to 1, as the name implies, unit 1. Okay. So that is that about the unit vector. Then there's also what we call the dot product of vector. There's also what we call the cross product. So let's look at the dot product. So I have dot product, or you call it a scalar product of a vector. So if the vector A is equals to A1I plus A2J plus A3K, and the vector B is equals to B1I plus B2J plus B3K, and I want to look for vector A dot vector B, we call dot product. Dot product, it means at the end, your answer will be a scalar, because dot product means scalar product. That means in your answer, no unit vector will be attached to it. I, J, K will be absent. So how do we get the dot product? We'll just multiply the corresponding coefficients and add them together. That's all. So this will give me, on the I component, the coefficients, A1 times B1 will be A1 B1. This times is A2 B2. This times is A3 B3. And that's the answer to the question. So e.g., let me give you the ones that involve figure. If the vector A is equals to 7I plus 6J minus 4K, then the vector B happens to be 2I plus maybe 9J plus, let us say, 9K. So we are being asked to look for, so if A is this and B is this, they say you should find vector A dot vector B. So that's the dot product. So here, solution, vector A dot vector B means I'll multiply the corresponding coefficients. 7 times 2 is 14. 6 times 9 is 54. Negative 4 times 9 is minus 36. So here, this will give me 14 plus 54. That will be 68 minus 36. Take one from here, add here. No, 8 minus 6 is 2. Then 6 minus 3 is 3. So this is 32. And that is the answer to the question. So the dot product means scalar product. That means at the end, the answer will be a scalar quantity. It's different from when we go to cross product. In our case of cross product, the unit vectors will be attached to it. I, J, if it's 2 dimension. If it's 3 dimension, I, J, and K will be there, because cross product means vector product. That means at the end, your answers will contain those unit vectors, I, J components, and so on. Okay, so we are done with the dot product. So let's go now to the case of the what? The cross product. So cross product, you can call it cross product or you can call it vector product. So let's get an example on that. So if the vector maybe A is equals to, let's say maybe 5i plus 3j minus 2k, then we'll have maybe vector B, and the vector B is equals to maybe 2i plus 6j plus 8k. Then you are being asked to find the cross product. That's what we call A cross B. You don't write it that way, you can still see it in the exam like this. The cross can be written like this. I should find the cross product. The best way, remember, cross product or vector product, that means at the end, the answer will be of this form. The answer will also have the I, J, and K components, because those I, J, and K are the unit vectors. And the best way of doing this thing is using the determinant method of a matrix. Yes, that's the best way of doing it. So solution. So we'll have A cross B will be determinant of, so here is I, J, K, we'll take it, I, J, K. Then the coefficients of I here we have is 5 and 2. So here will be 5 and 2. Coefficients of J is 3 and 6. The coefficients of K here is minus 2 and 8. Minus 2 and 8. Those are the coefficients. So getting the A cross B simply means I should get the determinant. This thing is considered as a 3 by 3 matrix. It has how many rows? 1, 2, 3. How many columns? 1, 2, 3. Now this is the Cartesian form of the vector. This Cartesian form, can still get it back from here. 5i, 3j, minus 2k is for this one. Then this one, 2i, 6j, 8k is this one. So now let's go. This will not, so I will now use plus, minus, and plus. So this will give us, we'll take this first person, I. So the determinant of a 3 by 3 reduces to the determinant of a 2 by 2. When I take this I, when I collected this I will not close it vertically and horizontally. I'm left with what? 3, negative 2, 6, and 8. Then I take minus j. Minus j. From there, I'll close it horizontally and vertically. I'm left with 5 minus 2, 5 minus 2, 2 and 8, 2, 8. Then I'll take plus k into where I took the k, I'll close it vertically and horizontal. I'm left with 5, 3, 2, 6. 5, 3, 2, 6. So now to get the determinant of a 2 by 2 matrix, you multiply the elements in the leading diagonal, then multiply the elements in the secondary diagonal. That means we are going to subtract the product of the elements in the secondary diagonal from the product of the elements in the leading diagonal. So this will give us I into 3 times 8 is 24 minus 6 times minus 2 will be what? 6 times minus 2 will be minus 12. Here will be minus j into 5 times 8 is 40 minus 2 times minus 2 is minus 4. Then I bring down my plus k. Then I'll take 5 times 6. 5 times 6 is 30. Minus 2 times 3 is 6. So this is going to give me minus times minus will be plus. So 24 plus 12 will be 36. So this is 36i. Then here, minus times minus is plus. So 40 plus 4 is 44. That will be minus 44j. Then here will be plus 30 minus 6 is 24. 24k. So you will say, therefore, vector A cross vector B. This will be the answer. So that's what we'll call it cross product or vector product. Because at the end, the answers will have the unit vectors I, J, and K in their respective directions. So please, if actually you are interested in maybe you like the live stream and what I'm doing, just you subscribe to my YouTube channel. Yes, then my niche is not just on mathematics. Yes, I also teach on physics, chemistry, further mathematics, and biology. So just you go to my YouTube channel, just when you subscribe to my YouTube channel, just go and watch the videos. You see that all those various topics, both O level and advanced level, biology, chemistry, physics, maths, further maths. So all those things are being done very well. Then you can also follow me on TikTok. Yes, using this link. Yeah, so we'll be having organic chemistry and physics. Yes, by 10:30. We're doing organic chemistry and physics. Yes, on TikTok. Yes, by 10:30. So if you have any question, you can drop it on the comment section. Then I'll listen to you. Or you can also DM me, and then you have any difficulty, then I will be able to attend to you. So we're going to stop here for today. Yes, then those of you maybe down on TikTok, yes, you can still join me by 10:30 with this link. Yes, where we'll be doing my organic chemistry. Yes, I will be doing organic chemistry and physics. Yes, and that lectures will last for a very long time. So thank you for watching my video. Bye.